There is an intentional typo here. Recipe tasting with a tin of beans. What on earth does that mean? My industry is software testing. I come to IT from a sort of a different angle to a lot of people. My degree was environmental science. I started working as a software tester. I love this industry to bits. I think I have the best job in IT, and I will challenge any developers, any project managers, any day for a game of top trumps, and software testing will win because testing is the best job in IT. So I had a choice today. I could try and sell you my job and my career. I could watch you all fall asleep, even though it's exciting for me, or I could tell you a couple of quirky things. So I've got basically two things I want to give to you today. The first one is why I think software testing is the most important thing in IT, why I think is the most interesting thing in IT, and why everyone should go into software testing. You know. But secondly, how do you do testing, and how can you avoid doing bad testing? And this can involve any project. So whether you're writing something in Scratch or something in Python or Raspberry Pi, big mainframe system, any system you could think of in the world, you know, testing that software and making sure it does what it should do, that you validate it against the requirements, is absolutely essential. But first, I said I had the best job in IT. And this is why I have the best job in IT. I get paid to break things. You know, I get paid to be destructive. It's lovely. I get to sit there in an office and I get to destroy things. Well, that's what I used to say to people. You know, it's true, I do get paid to break things. It's quite nice being paid to break things, but that's not really what my job is. Paid to break things is very after the event. That implies that someone's given me something and I wait until they give it to me. I don't even consider it really until they give it to me. And then I start kicking it and I see what happens and it falls over and I give it back to them and we fix the bugs and we go around in a circle. So I do get paid to break things, but it's a bit of a simplistic way of viewing things. That will work better, won't it? So maybe, and probably a better way of describing this, is that I get paid to ensure things don't break. Because if I'm ensuring something does not break, we're now talking about getting involved in something earlier, getting involved in the software development phase, the testing earlier, before something has broken. That's got to be a good thing. Because if I can stop it breaking in the first place, that has to be better for everyone's morale. It's not very good when you see software breaking in front of you and a deadline is looming and we're going to be late in delivering the software because we can't make it work. Surely let's just make it work in the first place. So I then moved on to starting to say to people that basically, as it says up here, you know, I get paid to ensure things don't break. But that's not quite it either. That's a bit simplistic too. And it's simplistic really for one reason, and I've got it up here. You know, it's about possibility of breakage. I don't want something to break in the first place. So really, as I said here, I get paid to prevent the possibility of breakage in the first place. But this is an interesting idea. It's an interesting concept. If I am testing and I am preventing something from failing in the first place, then I have to be testing it from day one. But we don't have the software on day one. You know, the first day you buy a Raspberry Pi, you have a Raspberry Pi. You don't have software that you've programmed. So how can you test the software on that Raspberry Pi before you have written the software? It kind of doesn't make sense. It seems like it's the wrong way round. But it's exactly what I do. We purposely write our computer software at work in such a way that we will write our tests at the same time, or ideally, and quite often, before the developers will write the code. So I had a good one, funnily enough, just yesterday. So one of my testers on my team had written a test based on a requirement that we'd agreed that this requirement would be different to what we'd originally specified for the software. That's fine. We can cope with change like that. And my tester had written the test case. We ran the software against that test case, and the software naturally fails. We've not programmed the software to do this new thing. That's good. We're okay with that. We're happy with that, because then we can give that test to the developers. The developers will then code their software to do exactly what our test says, which basically means we end up with working software. So that also means we end up with no defects. So we have software that is being released that has no known defects in it. Yes, it will have bugs. Every bit of software has bugs in it. There will be things we haven't found. But we're in a position now where we're writing software that's squeaky clean, that's going out the door in such a nice way. And this is a good place to be in. So really, this is what I do as my job, is I prevent stuff from going wrong in the first place. I'd say that's more interesting. But that's what I actually do. And you can combine the two together, because I get paid to prevent things from breaking. However, if they do break, I'm also there, my team is there to ensure that we basically look after stuff going forwards. Now, there is a phrase in software testing that will make every tester cringe. And this is the phrase, test it. We'll cringe and we'll frown. So if I come up to you and I say, can you test this? And I just give you a thing and say, test it. You're going to sit there and go, well, test what? Yeah, it's blue, it's square, it's not edible. Is that what you mean? What do you mean test it? Give me something to go on. It makes us frown. It makes us frown in a bad way. Now I need a volunteer at this point. This is my software. Doesn't look like software, but it could be software. It doesn't really matter. And I need a volunteer. Hello, John.
Hello.
John,
Yeah.
Test it.
What do you want to test it against?
Exactly. Let's help John out. So John has basically asked a perfectly valid question. How on earth can he test that when I've given him basically a dog? By the way, the dog's called Loopy. He likes to be referred to as Loopy. He was brought in Loo in Cornwall, so he really is called Loopy. Yeah. So how does John test that? What? It makes absolutely no sense. It makes as little sense as someone giving me some software at work and saying, test it, and giving me nothing to go on. Now, that doesn't happen. We have good processes and good practices in place. But in a lot of industries, in a lot of companies, that does happen, and no tester should ever put up with it. Because what can happen is, people turn around and say, as John just did, what do I do? So, John, I'm going to give you something to help you work out how to test Loopy.
I still don't know what you want me to test. Do you want to test how robust it is? What do you want me to do?
Exactly. I've given John some requirements, but they're really badly written. They're written in the form of a dog and a hammer. It makes no sense at all. If anyone else would like to test the dog later with the hammer, maybe. John, you're absolutely right. So what kind of stuff would you want to know about that?
Well, I'd want to know what you wanted me to do with that. Give me a tool, you give me something I can use.
So now John's thinking just like a tester. I've given him a tool, it's something he can use. It's almost like I've planted him or something. I promise you I haven't. He's just asking all the right questions. Yeah, exactly. What do you use the hammer for? So if I say, well, actually, the hammer is to build a dog house for the dog to live in while you're testing the dog, you suddenly going, the hammer's got nothing to do with testing the dog. It's totally unclear. What we need to do with that hammer and with that dog. I won't make you stand there for the next 5-10 minutes because it feels unfair somehow. So this is the point. If you get told the phrase "test it," then we are really just giving you vague information. We need proper requirements. We need a user story. We need something where someone says this is what the software should do. The important point there is that it's that what it should do, not what it does do. So think of a calculator. What it does do is you press a number appears on the screen. You press a symbol like plus, a number appears on the screen. You press another number, 2. You press equals, things appear on the screens. It does calculations. That's what it does do. What it should do is it should do what a calculator should do, and you should define that as a series of requirements. However, I don't know how easy this is to read back there, but basically just going through it, it's hard to define all the requirements up front. Requirements change. If I say I want a calculator now, by the end of it, I probably want a smartphone. Things change all the way along. Trying to ensure that you have the correct requirements from the outset is extraordinarily difficult. It very rarely works in industry, very rarely works in IT. And it leads to a problem which we call reactive testing. So someone gives me the dog, and they say, test it. And I start pulling his ear. Well, no, I better not pull his ears. Probably wouldn't like that. But, I start pulling the ears of the dog. And that's not really what we want. What we want to do is build a dog house for the dog. And actually the test is to see if the dog likes living in the dog house. But, but they're going, who likes living in dog houses? So the thing is, though, if we don't define those requirements up front, we stand very little chance of actually getting a decent bit of software out at the end. But we also can't define all those requirements up front because they're going to change. So this means we get reactive testing. We verify what the software does do. It does this because I can see it in front of me. I press 2 + 2 and it equals 4. Rather than verifying that what it should do is actually it should do the functionality of a smartphone, because really it was a smartphone we were after, not a calculator. So testing ends up playing catch up. Testing becomes a very reactive process. It's after the developers have developed the software. It's after everybody else has been involved in it. And testing is at the end of the process. And testers then end up sitting there and they end up manually mashing the keyboards and manually mashing buttons, trying to test, trying to get things done in a short amount of time. And it's panic stations and everything goes wrong. It doesn't have to be like that. And where I work, it's not like that. You can do something about this, and you can do something about this in your own programs. Now, the interesting thing here is if you're programming on the Raspberry Pi, and you're doing something in Scratch or you're doing something in Python, you can have the exact same problem. If you're working as part of a club or part of a group at school, and someone says, right, I want you to design this. I want you to go out and make a camera that, with the Raspberry Pi that sits on a bird box. Well, actually, that's not bad for a high-level description of what it should be. But what should it actually do? Because a camera next to a bird box doesn't do anything unless we give it some instructions. So do you mean you want an infrared sensor so that when a bird flies past, goes in through the entrance of the bird box, we see that and that takes a photo? What is it you actually want? And we can define this. And this is the mechanism that I use at work and that you can use. And you can use it. I've got an example over there, actually. I can show anyone later. We use Behaviour Driven Development. Now, this is a way where you start with testing. Well, actually, you start with gathering those requirements and you test against those requirements, but your testing drives development. And do you remember what I said right at the start? The 3 things that I do. Do I break software? Actually, what I really do is I prevent it breaking in the first place. This is what I'm getting at. We write those tests before we even start. And this is great things to do, because if I write the test with that hammer and with that dog before I give John the hammer and the dog, John doesn't stand here looking slightly embarrassed in front of you, all holding a hammer and holding a dog. I feel like I should have got you to stand there for another 10 minutes, but there you go. So what do? Well, we take a single requirement. We don't take all the requirements. We take a single requirement. We write whatever tests are necessary for that requirement, but only the tests that are necessary for that requirement. We then execute those tests, and we do this automatically. We don't manually press buttons. Any software tester who is sitting there, at home, watching this on video at the moment and saying, oh my God, my job is I just sit there and I manually press these buttons. That's a bad way of doing testing. As an industry, we've moved on a long way from that. We automatically execute these tests. Once they're executed, well, they're going to fail. We've not written the software yet. I've written the test, I've run the test fails. But I give that package to the developers. And the developers now know exactly what they have to program. They have to program enough and only enough code to make those tests pass. So the requirements can change. We can get new requirements in. The tests can change. We can get new tests in. And the development and the activities follow the test, which follows the requirements. Everything stays perfectly in sync. Here's an example. Now, we write this in what's called Gherkin syntax, and Gherkin syntax is a human-readable syntax. And I put something down here involving Raspberry Pis of the edible variety. I would suggest not running this test with an actual Raspberry Pi of the hardware variety. It would make your teeth break. So, for example, I've said here, there's a feature. The Raspberry Pi is baked, and I want to determine that it tastes good. And we use a standard syntax. So we just say, in order to determine that the pie tastes good, as a pie eater, I want to sample the pies. This is always defined in terms of the user. I am a pie eater. I enjoy pies. Pies are good. Everyone should eat pies. So I want to sample the pie. So we have to write a scenario for that. We actually have to write lots of scenarios for that, but we might just write one to start with. So I'm going to eat the pie. So given I have a Raspberry Pi and it's hot and it's cooked, and I've taken it out of the oven, and I haven't burnt my hands on the pie case, etc. Whatever is necessary, whatever the conditions are, when I eat a slice of the pie, we can then define things about that pie. Well, I said here, I've got 2 up here. The pie crust should be crispy. The pie should taste of red fruit. Clearly, it's a raspberry pie. It's not a blackcurrant pie. So there's a specific expectation there in terms of the taste of the pie. So I can write these scenarios, and I can write that before I give it to the cook who cooks the pie for me. And the cook knows that they've got to cook a pie that's got a crispy outer case and taste of red fruit, if nothing else. Now, at the moment, it doesn't say it must taste of raspberries. It could taste of red currants, for example. But that would be another scenario where we would talk about raspberries rather than red currants. So we can build up these scenarios to define what a pie should actually be like. But let's give you a real example, something that actually makes sense in Raspberry Pi terms of the hardware variety. Lots of people make robots. Robot motion controllers are great fun. So if in order to test that my robot can navigate around obstacles, as a user who is issuing commands to the robot, I want to issue those commands to the robot to see what happens. So one of those commands that I need to be able to do is to rotate my robot to the right, because clearly if the object is there and I want to go around it, I may go around to the right. So the scenario is rotate robot to the right. So if I've given that my left motor is moving forwards while my right motor is stationary, when power is applied to the robot should turn right. And that's a scenario that we can then code against and we can define and we can test against. Equally, we could write another scenario that says when I apply power to the right motor and not to the left, that the robot turns left. And when I apply power to both motors, the robot drives forward. So we can build up as many scenarios that are necessary to define what this robot should do, should define the features of this robot and the scenarios that accompany the features of that robot. And we end up with a big long list of those, and then we can execute them. Now, I'm not going to bore you today by going into what are called step definitions, so the code behind the scenes, because although that, as seen on the screen at the moment, will execute, and I can show you, well, not that particular example, but I can show you another example executing on my over my stand. There's a lot of Python code behind the scenes that makes that actually do something. But let's not worry about the Python code today, because this is about the idea that there's a clever way of doing testing, BDD, Behaviour Driven Development. You can use it from the most simple, straightforward project, your very first project, up to the most complex thing you've ever worked on in the industry. It scales beautifully. I've got it for some particular projects I'm working on at the moment over there. If anyone knows about floating point arithmetic and wants to come and give me a hand with a particular problem I've got something over there that I can show you this. I can show you this genuinely finding a bug in my code that I'm currently struggling a little bit to fix, but I'll fix it eventually. But I found that bug because of what this gives to me. So, a couple of things just to show you. So, the software should do, and I said at the start, it's, Raspberry tasting it with a tin of beans. So the software should do what it says on the tin. It should do what it should do, not what it does do. And so much testing ends up becoming what it does do. It's reactive, it's after the event. BDD, Behaviour Driven Development, whether it's school projects, university projects, or working in industry, it really doesn't matter. It ensures, absolutely, you stay looking at what the software should do. You validate against the requirements, and those requirements can constantly change and evolve, so you can improve your projects as well. We get free regression testing. Now, regression testing basically means that we're going to rerun the same test cases over and over again. Now, I put down here, the new tester's mantra, I'm not clicking any more buttons. Now, if you think about it, you've got version 1 of a piece of software, and it's got this much functionality. When version 2 of the software is added, you've now got this much functionality, and you need to test version 2's functionality, but you must also regression test version 1. And now I have version 3, 4, 5, 6, and my arms won't go any wider. And now I have to test version 6, but regression test everything in the middle. If I am manually doing that, and I'm manually pressing these buttons, and I'm manually running these tests, it quickly becomes evident that I cannot keep up with that unless I keep buying more and more test resources into my team. I hire more testers. It becomes implausible, it becomes expensive, and we will miss things because it is boring running the same test over and over again. So at a school project, at a university project, or in industry, as I said, it really doesn't matter. It applies to all of them. You can get free regression testing. Every test is executed every build of the software, so you always know the quality of your software. And the gold standard is you always have 0 known open defects. So we have a test suite at work, has thousands of test cases in it. It is currently running with 0 defects in that code that are known about. Of course, that code will have bugs. All software has bugs, but we ensure that we have as many test cases as we possibly think we need to cover all the functionality, variants on the functionality, and how it's going to work. And so this gives us this great advantage where we can basically turn around and we can present reports to the business and to our clients, and we can say our software is working with 0 known defects in that code. This software is therefore guaranteed to be fit for purpose, and that is a brilliant and beautiful thing to be able to say in testing. Just a couple more slides, really, just to kind of wrap up. So behavior-driven development. There are lots of ways you can use behavior-driven development in Python. So in Python and other languages, whether it's Ruby or C#, C++, there's lots of tools you can use for this. Now, I particularly use a tool called Lettuce for no particular reason other than it fits my needs. It fits what I need to do for my projects. Your tool of choice may be something entirely different, and that's perfectly fine. You can install Lettuce very easily through Python, and I've got a couple of commands to do there. I'm going to make these slides available up on my website. So after this, so I'll get that URL published, so you can all get access to this. So don't worry about writing this down. You can always come and have a look at these slides on my stand. So the slide's going to be available, so there's no problem there. But the point is, you can install it, you can run it, you can do this yourself. Last slide. I feel like it's death by PowerPoint today, but that's a good thing, isn't it? Yeah. So development is driven by testing. Testing is driven by the business. That is the correct way round. Too much software falls into the trap of the developers saying, well, what we're going to do is this, and what we're going to deliver is this. And that's okay up to the point of actually getting some working code, i.e. it does what it does, but it's not okay in terms of meeting your clients, meeting your business, meeting the people out on the street who are using your software day to day as part of their lives. You know, if you had a device like the iPad, and the only software that was developed for the iPad was the software the developers themselves made and used and created and wanted to use for themselves and no one else, or they only coded the software that made sense to them because that's what they were working on at the time, then you wouldn't get all the wonderful applications that everybody can use. So it's very important that the business, the clients, the customers, the end users drives testing, and testing drives development, and that gives you the correct workflow order. We put focus on the behaviors of the system. So we worry less about individual functions of the system. So I said it's not so much about the calculator doing 2 + 2 = 4, although of course that is important. It's more about the behavior of the system. Well, actually, the behavior is I really want to calculate an application on my smartphone. I don't want just a calculator. So there's a whole set of behaviors around that. I will expect the software to do from a user's point of view. We welcome change. This is the most important thing. And you talk to a lot of software testers and you say, oh, the requirements are changing and you're going to have to redo your tests. And you just watch faces drop and people get very gloomy about this. The amount of manual testing, the amount of manual regression testing I'm going to have to do, I can't stand this. What am I going to do about this? People turn around to me and say, we're going to change stuff. I just smile. I love change. Change is a great thing because if I'm changing something and it's because the business has said they want it changed, that means we're making better software for the end users. The end users have said, actually, it would be much better if I had that in blue rather than had that in pink, or it would be much better if I had a widget over here rather than a widget over there. Well, you know what? The user has said they want a widget over there. Let's give them a widget over there, and let's have a way of testing that ensures they get a widget over there and it works. And that's what BDD gives us, behavior-driven development. It's a really good thing. It keeps testing and development in step with the needs of the end users. So everybody's talking the same language, everybody's working together, and that's just fantastic. And that's me done. Thank you.